Hello students, in this class I will explain the miscellaneous exercise of chapter 2 class 12, which is related to inverse trigonometric function. So I will explain how the questions are solved also. The first question number 1 is cos inverse cos of 13 pi by 6. So this is equal to, as per rule, this is cos inverse cos theta. We know cos inverse cos theta is equal to theta if theta belongs to this interval 0 to pi. So here you see 13 pi by 6 is not in this interval, so this is not equal to 13 pi by 6 since 13 pi by 6 not belongs to this closed interval 0 to pi. This is not equal. Cos inverse cos 13 pi by 6 is not equal to 13 pi by 6. Although the formula says cos inverse cos theta is equal to theta, but here one domain you have to take care of. Theta should be belongs to 0 to pi, then only this one. So how to make this 13 pi by 6 belongs to this interval? So now cos inverse cos 13 pi by 6, we can write this as cos inverse cos of pi plus twice pi plus pi by 6. So this is equal to cos inverse cos pi by 6. We know this because cos twice pi plus theta is cos twice pi plus theta is cos theta. So cos twice pi plus 6 is cos pi by 6. So this is equal to pi by 6, as pi by 6 now in this interval, since pi by 6 in this interval. So in this way this question number 1 is solved. So let us try another one. Question number 3. 2 sin inverse 3 by 5 is equal to 10 inverse 24 by 7. So how to do this? Sin inverse 3 by 5. We know in this triangle, if sin inverse 3 by 5, if we take sin inverse 3 by 5 equal to theta, then sin theta is equal to 3 by 5, as 3 is our perpendicular and 5 is our hypotenuse, and this is our theta. In that case, by using Pythagoras theorem, this side is equal to 4. So base is our 4. So this can be written as twice 10 inverse. So LHS equal to, we have to prove this one. So LHS is equal to 2 sin inverse 3 by 5, which we can write as 2 tan inverse here, base by perpendicular by base, that is 3 by 4. We can write 2 tan inverse 3 by 4. Again we have got twice tan inverse 3 by 4 formula. Twice tan inverse, we have 2 tan inverse x formula. Twice tan inverse x is equal to tan inverse twice x by 1 minus x square. We have got this formula. Tan inverse x is equal to tan inverse twice x by 1 minus x square. Using this formula, 2 tan inverse 3 by 4 is equal to tan inverse twice x means 2 into 3 by 4 divided by 1 minus 3 by 4 square. So let us simplify this, then you will get the RHS. So this is equal to 3 by 2, 1 minus 9 by 16. And which is equal to, if we simplify this one, tan inverse 3 by 2 divided by 16 minus 9, that is 7 by 16. So this is equal to tan inverse 2 8s are 16, so 8 3s are 24 by 7. So it is proved. So in this way it is proved. Let's try another one. Let's try another one. Question number 6. Cos inverse 12 by 13 plus sin inverse 3 by 5. Sin inverse 3 by 5 is equal to sin inverse 56 by 65. Sin inverse 56 by 65. So LHS is equal to, same way, LHS is equal to cos inverse 12 by 13 plus sin inverse 3 by 5. Now if we draw the triangle here, then to a cos inverse 12 by 13, so cos theta is equal to 12 by 13, cos theta is equal to, that means cos theta is equal to 12 by 13. If we take this one, cos theta is equal to 12 by 13. Cos inverse 12 by 13 means cos theta is equal to 12 by 13. So cos theta is 12 by 13. That means 12 is base, 13 is hypotenuse. So obviously this is our perpendicular is 5 for this one. And if it is sin inverse 3 by 5, for sin inverse 3 by 5, 3 is hypotenuse, sorry, 3 is perpendicular and 5 is hypotenuse, so base is our 4. Thus cos inverse 12 by 13 is same as tan inverse perpendicular by base, that is 5 by 12 plus sin inverse 3 by 5 is sin inverse 3 by 5 is tan inverse 3 by 4. Now 5 by 12 into 3 by 4 is less than 1. So 5 by 12 into 3 by 4. 3, 4. So you see it is 5 by 16. So this is less than 1. So we can apply the tan inverse A. We can apply the formula tan inverse A plus tan inverse B is equal to tan inverse A plus B, that is 5 by 12 plus 3 by 4, 1 minus 5 by 12 into 3 by 4. So that is equal to tan inverse, if we simplify it, 12 is the LCM, then 5 plus 9 and here 16 is the LCM, and then 16 minus 5. 16 minus 5. So this gives us 10 inverse 5 plus 9, 14 by 12, and 16 minus 5, 11 by 16. So you cancel it. 4 3s are 12, 4 4s are 16. So we got this is equal to 10 inverse 56 33. 56 by 30, 10 inverse 56 by 33. So which is equal to 10, which is equal to sine inverse 56 by 65. 56 because 56, if you see 56 square plus 33 square equal to 65 square. So that's why this is equal to sine inverse 56 by 65 as root. So in similar fashion, this type of question we can solve very easily. A few more, let's try a few more questions. So prove that tan inverse root over x is equal to half cos inverse 1 minus x by 1 plus x, and obviously x belongs to closed interval 0 1. Here main is to substitute cos inverse 1 minus x by 1 plus x. We have to substitute x is equal to what? X is equal to what? So that it is becomes some cos of something, cos of some angle. So we have got formula cos 2 theta is equal to, we have got formula cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. This formula we have got. So you have to recall these formulas. So it can be compared with this formula. See, 1 minus, in place of x, if we substitute tan square theta, then it becomes 1 minus tan square theta divided by 1 plus tan square theta. So we will substitute. So this is very important. This is very important to substitute x is equal to tan square theta. Let x equal to tan square theta. So this implies root x is equal to tan theta. So this implies theta is equal to tan inverse root x. So this is. Now RHS is equal to, therefore RHS is equal to half cos inverse 1 minus x by 1 plus x is equal to half cos inverse 1 minus tan square theta by 1 plus tan square theta. So this is equal to half cos inverse cos of 2 theta. So this is equal to half cos inverse cos 2 theta is 2 theta. So this is equal to theta, and theta is equal to tan inverse root x. Hence proved. Let's try another one. Question number 11. Cot inverse root over 1 plus sin x plus root over 1 minus sin x divided by root over 1 plus sin x minus root over 1 minus sin x is equal to x by 2, where x belongs to interval, closed interval 0 to pi by 4. So LHS we start like this. LHS is equal to cot inverse 1 plus sin x root over 1 plus sin x root over 1 minus sin x root over 1 plus sin x minus root over 1 minus sin x. Now we know 1 plus sin x is equal to sin x. In place of 1 we can write cos square x by 2 plus sin square x by 2, because 1 is equal to cos square x by 2 plus sin square x by 2, and plus sin x can be written as twice sin x by 2 cos x by 2. In that case 1 plus sin x becomes cos x by 2 plus sin x by 2 whole square. So this is equal to cot inverse in all cases root over cos x by 2 plus sin x by 2 whole square plus this is equal to cos x by 2 minus sin x by 2 whole square, and the denominator also similarly root over cos x by 2 plus sin x by 2 whole square plus, this is minus cos x by 2 minus sin x by 2 whole square. So cos x by 2 root over cos x by 2 plus sin x by 2 whole square is equal to cos x by 2 plus sin x by 2. So let us remove the square root from each term. Everywhere we remove. So cot inverse, if we remove the square root, then it becomes cos x by 2 plus sin x by 2, because cos x root over cos x by 2 plus sin x by 2 whole square is cos x by 2 plus sin x by 2, and plus this is equal to cos x by 2 minus sin x by 2. you may say, some student may say that it may be sin x by 2 minus cos x by 2, but it will not be sin x by 2 minus cos x by 2, because cos x by 2 minus sin x by 2 is positive in this interval 0 to pi by 4. In this interval, when x belongs to 0 to pi by 4, cos x by 2 minus sin x by 2 is positive, whereas sin x by 2 minus cos x by 2 is not positive. So square root of cos x by 2 minus sin x by 2 whole square is always positive. So we are taking cos x by 2 minus sin x by 2 here, because cos x by 2 minus sin x by 2 is positive and sin x by 2 minus cos x by 2 is negative. So it cannot be sin x by 2 minus cos x by 2. So here also same, cos x by 2 plus sin x by 2 minus cos x by 2 plus sin x by 2. So this is equal to cot inverse cos x by 2 plus twice cos x by twice sin x by 2, 2 cancels. So this is equal to cot inverse cot x by 2, and which is equal to x by 2 hence root. So in this way we can work out the examples. Okay, thank you.